Astra podcast, episode 2. Mars and how to help science fiction writers with science, with astrogeologist Jonathan Sneed.
Hello, welcome to the Ex Urbe Ad Astra podcast, where we talk about the craft of writing, history, science fiction, fantasy, science, and other nifty topics.
Hello, I'm Jo Walton, science fiction and fantasy writer and vocateur reader.
And I'm Ada Palmer, also an SF novelist and a historian of European thought, censorship, books, the Renaissance, and today, people's efforts to save the souls of their dead parents using architecture, which is what I was reading about this morning.
And today we're going to talk about Mars and also about answering science questions from science fiction writers with our awesome friend Jonathan Sneed. Welcome, Jonathan. Do you want to introduce yourself?
Yes, I'm glad to be on the podcast. Like I said, I'm Jonathan. I am an expert in Mars surface processes, which is a fancy way of saying that I have done a lot of Mars wind science and erosional science. I'm a geologist that's done a lot of following the water with respect to NASA's astrobiology initiatives. And I have also done some consulting work for science fiction authors on how to properly incorporate different scientific facts into the writing process and the best ways to do that. So I have a little bit of experience with both major topics for this podcast, which I'm looking forward to talking about.
There's an art or a skill of being a scientist who is good at giving answers that are useful to science fiction writers. Many scientists are brilliant scientists, but actually not good at giving the kinds of answers that you can then use in a book. Whereas Jonathan is an example of a scientist who is also separately skilled in giving the kind of answer that is useful for writing a book. So it'll be fun to talk about that.
Yes, although my day job at the moment is that I am a graduate student currently earning my PhD at the University of California in Los Angeles, and also currently doing internship work at the NASA Jet Propulsion Laboratory. So I will hopefully be able to talk a little bit about the kinds of things that are going on in space exploration right now. I also need to put in a little bit of legal boilerplate here. Although I'm an intern at JPL, I am in no way speaking for JPL. This is not an official JPL release of anything. I am speaking only as myself. I am on the podcast as a guy, and not
as an astrogeologist.
Yes.
just any astrogeologist, you know.
Yes. Just the most boring kind of space exploration. Right?
So I think a fun place to plunge into talking about what your Mars research is like is I remember a period when you were looking at the traces of a river, and there was about a 4 to 5 day period in which you weren't sure whether it was the longest river in the solar system. But it might be, and you were continuing to sort of follow it and see how long it was and compare it to the Amazon and the Nile, and every day you would get a bit longer and not be sure which one would win.
I think eventually Earth won out that one, yes. Unfortunate.
Yes, Earth did win.
Yes, a lot of my work is done on a very large scale. And I had a colleague once who described the current state of Mars research as very Victorian, by which he meant kind of two things at once. In the first place, we're asking very, very big questions about this whole exciting new world. And so we're asking questions that seem really, really basic. You know, if you're a Victorian geologist in the late 1800s, for example, the field of geology is at this point, still relatively young. We don't know anything about plate tectonics yet. We're not entirely sure where those mountains come from. And
in
so
the 19th
we have
century, you mean? Yeah.
Precisely. Yeah, and so you're asking these very, very basic questions and some very, very broad questions about the behavior of a planet as a whole. And on Mars, we still have this same mentality that 18th and 19th century geologists had for Earth.
Right. So sort of, why does Earth mountains? How does Earth mountains? Okay, now we've figured out how Earth mountains. Now, how does Mars mountains?
Exactly, and there is in fact still active debate about how to make Mars mountains. There are these features called sedimentary mounds that are often at these giant mountains made of accumulated dustfall and sand and sediment in the middle of these craters that could not possibly have gotten there in the same way that Earth mountains do. And there's been contentious debate about exactly where these come from. And we eventually were able to show that they grow from the top up, where because high peaks on Mars are the warmest places because they have sunlight exposure for a longer fraction of the year, only on the top of mountains would you sometimes very rarely get frost melting forming water, which has the chemical ability to break down loose grains and form rocks. So deep in the shadows underneath the rims of these craters, you couldn't form new rocks, but only up high in the middle you could. So you get mountains growing where, high rocks get higher and low rocks stay low, which is the exact opposite of how it works on Earth.
Right, because in Earth it thrusts up from underneath, whereas here it's building on top.
Precisely. And so we still have to ask these very, very fundamental questions. There's open debate about where these huge features come from. Like the northern hemisphere of Mars is 1.5 kilometers lower than the southern hemisphere of Mars. And we have these really heated discussions about, was that perhaps a giant impact crater and the entire northern half of Mars is one crater? Or was there some sort of halfway tectonic action that got started and then never fully matured like it did on Earth because the planet is too small? And, you go to conferences today and you still see these very open questions about, fundamentally what is Mars as an object.
Neat.
If you could see my face, I'm sort of sitting here with my mouth open and this sort of expression where what I want to say is just amazing. After every sentence, it's just so wonderful to think of there being all of these huge open questions and you being at the forefront of finding the answers to them. It's just wonderful.
Well, it sort of reminds me of when I'll sometimes get an email of a person saying, people email history professors randomly with history questions sometimes. And when you write back and say, the answer to that question is, we don't know yet. We're working on figuring out. They're always flabbergasted. People are always really surprised that there are history things that we just don't know yet. And also, people tend to be really shocked if I say, oh, well, that archive isn't digitized and hasn't been translated. And they'll say, well, surely we've translated and scanned everything. And like, no, we've translated and scanned less than 1/10 of 1% of everything. And people just expect, any pre-modern document to be famous. But I mean, it's a sort of a comparable thing. I think that people who are researchers are very aware that we know an inch of what we want to know. But when people are not in a field and are very used to looking things up in an encyclopedia where it gives you a tidy explanation, you tend to feel as if we know 80% of what we want to know.
Right, absolutely. People are so used to turning to scholarship as a source of authority that I think it can be very disorienting when they actually hit the edge of scholarship and then the business of inquiry is being conducted out here on the frontiers of human knowledge. And they kind of discover how comfortable we are as academics, as scholars, with uncertainty, and how in many ways our job is navigating and quantifying that uncertainty and trying to decide what can be known, what would we need to do to know this, rather than just what do we know. Right. And that has so many layers and is such a complex profession in itself.
Yeah, how do we figure out the answer to this question that we now have?
Mm-hmm.
So I know that one of the ways you work on figuring out the answers to the questions we have about how Mars, mountains, and so on requires you to go to Death Valley a lot and spend time in 110 degree heat. Can you explain why that is? And what do you do in Death Valley that helps us answer the question, how does Mars mountain?
Well, lots of wilting, I'll tell you that. Death Valley certainly has earned its reputation. I believe that just this week, Death Valley hit 130 degrees in Fahrenheit.
Oh. Whoa.
Yes. And in fact, one of my colleagues, one of the other people in my cohort, has a project out there right now involving measuring dune systems. And he had to put the project on hold because there was no way to safely take instrument readings where we deployed all the instruments. It was just too hot and too far away from the road, so you would have had to hike for 2 or 3 kilometers across this sand, and you would just absolutely be in danger. And so it was not going to happen.
So what kinds of tests and why do we do in Death Valley as opposed to doing them somewhere nice and comfortable like Portland or something?
Yeah, so Death Valley has a number of things that are very attractive about it. For our purposes, it's the lack of precipitation that does us a lot of good. What I'm doing in this particular program has more of a focus on modern Mars and Mars as an aeolian system. Aeolian here meaning wind-dominated. And the modern Mars is very dusty and very windy, and the surface is otherwise fairly inactive by geological standards. We can go out there and there are surfaces that have been just exposed and still for 3.5 billion years in a way that you'll never see on Earth. And so
because Earth has volcanoes and Earth has earthquakes and Earth has tides and Earth has rain and
rain is the one, yes. And specifically, its precipitation on Earth tends to rapidly degrade anything like craters or geologic systems that can actually record any kind of wind-dominated shift. And so there are a limited number of places on Earth where rainfall is so rare that we can very purely and straightforwardly measure the behavior of these, like the interactions of sand grains and dust and wind, and see how those play out over long periods of time without ever really having to worry about enormous amounts of precipitation coming in and dominating the signal. It's in the same way that a physicist might go to the North Pole, where the magnetosphere around the Earth is the only place that cosmic rays can come in. In the same way, places like Death Valley or the Atacama Desert are some of the only places on Earth where we can really understand the behavior of wind and sediment and how they interact without having
rain.
to... Exactly.
Neat. So the temperature doesn't actually affect it. It's the dryness that's the reason.
Precisely. In fact, because we're dealing with mostly like quartz and feldspars, and quartz is a very stable mineral. It's fairly indifferent to the difference between 70 degrees Fahrenheit and 100 degrees Fahrenheit. Mm-hmm. It's really not until you hit freezing temperatures that you have a problem.
Right.
Because then you have like freeze-thaw cycles, and you might crack the rocks and so on. And even then, that's just, again, the behavior of water. And so if it's dry enough, then we don't have to worry about that either.
Right. And then it's sufficiently Mars-like.
Exactly.
So what is an example or two of the type of experiment that you can then run in Death Valley?
So one experiment that we're running right now is that we've made science cubes full of different materials at different heights. And so there might be like some obsidian and some limestone and different kinds of rocks that are each sort of in an array where they're exposed to wind from all different angles and at different heights. And what we've done is we've placed them at different distances away from a place called the Bagnall Dune Field.
That sounds like it's full of sand.
Yes, very much so. And so what we're measuring out there is how rapidly each of those substances degrades in different directions away from the dunes. And so we're able to understand, say, okay, how rapidly might a given surface retreat in the presence of windblown sands of a given intensity, helping us chart out the long-term degradation and the long-term behavior of Mars, so that when we see a specific surface, we might actually be able to say something about the kind of sedimentary systems that were nearby, or how that surface may have been responding to, say, global dust storms.
Right. Because if you can calculate that, okay, this is made of this and therefore degrades at X number of millimeters per year, we can calculate where it was or how much sand it's been hit by or things like that.
Yeah, exactly. Another thing that we can do out there is there are a variety of features called alluvial fans. which are essentially large sort of aprons or sort of conical piles of debris that come in off the mountains on either side of Death Valley and form these jumbles, basically, of rocks and sand on either side. And these are interesting from a Mars perspective because we see a lot of the same thing on Mars itself. Where one of the ways that Mars is still active is that we see these alluvial fans come out and form on the walls of craters or wherever there's like sharp ledges. And
the inside or outside or both of craters?
More commonly the inside.
Okay.
That's just where it's going to be steeper on the inside of those rims.
Right.
But it might also be on, say, the walls of Valles Marineris. There are some spectacular examples. And those behave differently at different levels of moisture.
Mm-hmm.
So one thing that we can do is use the very, very dry conditions of Death Valley to sort of form a profile of the surfaces, the grain sizes, how big are the rocks, what are their properties that we can find out both on the ground and by satellite images, and how does that compare to Mars, and use that to say, okay, when this alluvial fan formed on Mars, there actually might have been some moisture contributing to that, because that doesn't look like a dry fall. That looks like a micro wet fall sort of thing. And so we can also use Death Valley's non-zero but very low moisture to try to probe the drawdown of Mars and understand its transition from wet to dry, and what kind of geologic record would have been left behind.
Neat.
And have you found any evidence that there was more water, that there were wetter eras?
Oh, yes, absolutely. I think the general progress of water on Mars has been Spirit and Opportunity proved that there was water on the surface of Mars. Beautifully, elegantly, immediately by finding what's called evaporites, minerals that can only form when there is a pool or stagnant body of water with chemicals mixed in, and then as the water evaporates and leaves residue behind, it builds a mineral behind it. And so when Spirit and Opportunity landed, they found these evaporitic minerals very quickly and proved to us very conclusively that there had been water on the surface of Mars. Then we sent Curiosity to ask the question, okay, if there was water on ancient Mars, was it habitable? And Curiosity was, again, able to send us this answer of yes. Using instruments on Curiosity, we saw that there were lakes and rivers moving in a surface environment that was home to a relatively thick atmosphere, possibly as thick as that. The clays being formed in those waters can only form at neutral pH, a pH around 7, which is to say, if you were on the surface of Mars 4 billion years ago, you could drink the water.
Wow.
The temperature was between 0 and 100 degrees Celsius, so it was liquid water, not boiling away, not necessarily freezing all the time. And so there's every possibility that if you had a gas tank feeding you oxygen, you could have walked around on the surface of Mars without a spacesuit.
Oh, wonderful.
And so Curiosity gives us this news as we learned over the course of a few years. And so that, we've answered the question, okay, there was water. We've answered the question, okay, it was habitable. There's only one question left. Was it inhabited? And so Perseverance, which just landed this year,
Yay.
is really optimized for the astrobiology question, looking for fossils. And so what we're really excited by now is the opportunity to make some genuine inroads into that question. Getting more and more excited in the scientific community every time we ask, could there have been life on Mars? We get a little bit closer to this, like, yeah, it was reasonable. Yeah, it was even more reasonable. And so the big uncertainty we have now is, okay, how likely is life to arise in a sustained habitable environment?
Right, because Mars would be sort of n equals 2.
Yes.
If Mars gives us a positive for this type of planet.
Precisely. And n equals 2, I forget who it was that told me this, but 2 is the most ridiculous number in science.
Okay.
0 is reasonable because many things are impossible.
Okay.
1 is sometimes possible. Sometimes things are unique. Very, very large numbers are reasonable because sometimes things are common. Mm-hmm. But nothing happens exactly twice.
Right.
And so if we find an independent genesis on Mars, then that pushes us towards this question of like, okay, how common is life exactly? Probably pretty common.
It lets us fill in another little bit of the Drake equation.
Absolutely.
If we find that. And when you think how tenacious life is on Earth, when you think about the life that we found underwater hot vents and
Yes.
things like that, and in volcanoes, we've got a lot of answers from Earth that seem really positive, that once
Yes.
you've got life, you'll get some. So, it would be so exciting to have some kind of answer from Mars. Wow.
Oh, yes, absolutely. Although you may have noticed I was a bit sneaky in my answer there. I said if we can find a second Genesis.
Right, because the next
Yeah.
question is, did Mars life get to Earth?
Or the
Would
other
be-
way around.
Though the former is much more likely, as I understand, Jonathan.
That's correct. This is a phenomenon called panspermia, the idea that life could hitch a ride essentially on debris traveling from one planet to another, usually mobilized by large impact events,
Boom.
meteor craters, and so on. And that kind of debris, because the sun dominates our local gravity well in the solar system, will tend to fall inwards towards the sun. So you'll notice that we have some putative Mars meteors on Earth. We have some putative Moon meteors on Earth. We have no putative Venus rocks on Earth that we can try to chemically assess.
Or Mercury.
Precisely. They all fall in. So if there is life on both Mars and Earth sharing a single Genesis event, the overwhelming likelihood is that we ourselves are Martians.
Right. And similarly, if the traces of chemicals associated with microbial life that we have confirmed in the upper atmosphere of Venus turns out to be microbial life, it's decently likely to be Earth-sourced microbial life.
Depending on how common you think panspermia actually would be, yeah.
Right. It would be hilarious if the Venus life came from Mars, but Mars missed us, and so there was two Genesises, one on Mars and one on Earth, and then Venus got the Mars stuff. So it's still alive and well on Venus. It just adapted to being, on ridiculously high temperatures, which is also, if you posit it happens because a rock happened to land in a place version could totally have occurred, which would be hilarious.
I don't think that's completely unreasonable, no.
I was just going to say that as a long-term science fiction reader who's read a lot of science fiction that was written before we knew about the modern states of Mars and Venus, and when it was reasonable to think that there might be intelligent Martians, I've read a lot of things where I'm thinking particularly of H.B. Piper's universe, where life evolved on Mars and was humans, and then came to Earth when Mars got cooler and couldn't support life anymore, and we are all Martians. And this is a thing that they discover by doing archaeology on Mars, probably in the year 2000, in a thing that was written in the late 50s or early 60s. And we're not going to get that, but at a microscopic level, maybe we will.
Yeah, I think that the fossil record ruins your fun a little bit as far as the notion of ancient astronauts, but only insofar as you imagine those ancient astronauts as human. That there really is a possibility that life is surprisingly mobile within solar systems.
Right, through the microbes or tardigrade type things that can deal with being in vacuum for a while, happening from one place to another.
Mm-hmm.
What are thoughts, if any, on the likelihood that inner rocky planet life could have, in the same Panspermia system, originated on Jovian moons?
That's an interesting question.
Because we have these different speculations about Europa or Enceladus. Enceladus, there we go. Enceladus, yes. Or Titan, etc., as also having the possibility of, because we don't know whether life is high probability or low probability. But if they did, would that have a comparable likelihood or a much lower likelihood of making it to Mars, for example, than Mars making it to Earth?
Oh, interesting. Well, nature has a fascinating way of making scientists speculating sound like kind of complete dunderheads. But I would say that I would think it's a bit lower chance. Partly it's that I would imagine most debris from the icy moons around Jupiter or Saturn
Get
would be
sucked
more.
into Jupiter and Saturn.
Exactly. It also has a much longer distance to travel. Jupiter is so much farther than Mars.
Right. So it'd have to survive that much longer without
Exactly. And so,
failing somewhere.
and thirdly, the icy moons, to the extent that they have ecosystems and may have ecosystems today, which is a very exciting prospect and is in no way ruled out by current observations. They're sealed. They're essentially underground.
Right.
And so a meteor impact on the surface of Enceladus will not liberate organic material at nearly the same rate as it would if it hit a robust ecosystem on the surface of a terrestrial world.
Right. Now there are the ice volcanoes. Could we imagine a rock hitting the ejecta of a ice volcano? Again, I see already how that's less probability than a rock just hitting Mars.
Right. Very few things are absolutely impossible in this world, which is one of the really cool advantages of being a scientist advising science fiction writers. But yeah, I think in some ways you don't necessarily need to invoke that. The plumes of Enceladus coming out of its southern poles are hundreds of kilometers high, and while they don't necessarily have a rocky surface to latch onto, burrow into, or act as a craft taking it to the inner worlds, they're also already conveniently floating around in space. And so it may be that there's some kind of advantage from, say, like spores being able to survive the freeze-dried process of space for long enough, or something like that. We're certainly mobilizing a lot of carbon-rich organic molecules out of the Enceladus Ocean right now.
Right, in a way that Earth doesn't really eject.
No, nothing like it.
Yeah, except in JoJo's Bizarre Adventure, volcanoes don't shoot biological specimens out of orbit.
They probably do some. But it's it's tiny amounts.
Yeah, not as much as giant multi-thousand kilometer ice volcanoes being a regular phenomenon.
Right. Also, we're talking about icy moons with a total gravitational pull of 0.15 Gs.
Right.
Escape velocity off of the icy moons is just a lot lower.
So even if you weren't in a way,
even if you weren't physically blasting organic molecules into space, it would still be a little bit easier for certain molecules to just make their way out.
Right. But then they have the problem of being right next to Jupiter.
Yes. And also of being naked.
Yeah. Which isn't as likely to survive the trip from there to Mars, which is so long, as opposed to Mars to Earth, which is shorter.
Exactly. Many of the things that blow you up on the surface of modern Mars and prevent a robust ecosystem there today are what prevent any kind of transit of these organic molecules across the solar system. It comes down to ultraviolet radiation. Will just absolutely wreck you.
Right.
Will disassemble your molecules very quickly.
As we learned from the Chan video at the Smithsonian, which is why I paused. So in addition to Death Valley, I know you also work with wind tunnels in order to learn things about the modern surface of Mars. How do they help answer our questions about Mars?
Well, the function of a wind tunnel is really the same function as any kind of laboratory environment, which is that it lets you do the exact same thing 10,000 times in a row.
Right.
It's all about the controlled conditions. It's all about teasing out all the variables that you don't care about and excluding them from everything, and being able to just simply apply only the forces you mean to apply in the systems you mean to apply them in, and then observe the behavior.
So what's an example of what a wind tunnel actually does? Because, we're used to seeing them as a place where, bad guys might fight James Bond or something, but...
Right. And they're seen very commonly in engineering to test the behavior of wind around a certain object, or about, how, when you're moving at a certain speed through the atmosphere, what kind of stresses are you going to be under, that kind of thing. For me, as a geologist, as a scientist, it's a little bit different, but still fundamentally the same principle. So one thing that I did fairly recently was I've been trying to understand how different surfaces respond to long-term wind abrasion when there's sand grains bouncing along this surface.
Mhm.
So what I did is that I coated the floor of this wind tunnel in super light polyurethane foam, and then rigged up a giant bin of sand that I could refill every couple of days,
Mhm.
and supplied it to the wind tunnel while it was moving through at speed. I called it the Sedicator Mark 8, I think is the iteration I got up to. And then I could put different objects inside, and to create different types of sort of hypothetical or analog Mars surfaces, and see how they eroded over weeks or months, hundreds and hundreds of hours of sediment flowing over these, and look at the patterns of sediment deployment across them.
So the wind tunnel would be running for months?
Oh, yes. I had the wind tunnel running from December through, I believe, the beginning of March.
Running one simulation of sand moving
Yes,
along
one
and
experiment.
eroding something?
Mm-hmm. Yeah, one experiment over the course of about 2.5 months, with some stops. It wasn't totally continuous, but it was functionally continuous, and got some very good results. What I'd done on top of that is, because it's this nice controlled environment, I got some connects from the old Xbox game peripheral and
Okay.
plastered them all over this wind tunnel. And had rigged up a program to take 3D surface snapshots of my super light surface that was being eroded by this sand every hour for each of those 3 months.
Okay.
And was able to make a little movie or like surface of how in real time, with precise measurements, this surface sort of degraded, and be able to create surface height maps and show in a very precise quantified way how all of this changed over time. I didn't choose that because they were cheap. I chose that because, believe it or not, it's the best on the market.
Right. Yeah.
Entertainment applications can often be light years ahead of where a lot of technology is, just because there's so much money moving through that system.
Yeah, it makes a lot of sense. I'm reminded of how often when I watch the Robot of the Year awards, there'll be very complicated, sophisticated robots that do surgery and that do planting rice in a rice paddy. And I remember they made a robot scorpion that very effectively hit your hand really hard with its stinger thingy if you put your hand near it. I was like, okay, I'm not quite sure what that is. Great. I'm glad it worked really well. Good job, scientists.
Yeah, now go home.
But so often the winner is the latest toy interactive robot pet or robot, dancing robot. Because the budget that is behind the development of that robot is so huge, and therefore they can do a lot of new stuff in it, so that people who are real experts on robotics will analyze all these different robots and say, yeah, the greatest leaps in robotics were made by this cute little dancing thing, not by the rice paddy or the scorpion.
Yeah, and to some extent that makes sense to me, and I've kind of made my peace with it a little bit. It's easy to have the conversation about how that that feels kind of frivolous, but to some extent, I'm not too surprised in the end that the things that move technology forward are the things that can very directly help people tell stories and participate in these stories for each other. That is a very important part of our lives, and I think it's one of the things that we're most likely to want to get just right. It's the place that whenever we're especially doing things like representing other humans, that's such a challenging thing to do in art. And it's something that sticks out so much like a sore thumb when we don't quite get it right.
Yeah.
As a technological frontier, we're really pressured in our ability to tell stories, and especially tell stories about ourselves, and sort of follow through on all these big human dreams. That it is a place where technology really does matter.
Yeah, I think that's a great way to think about it. And I don't think I've ever heard anyone put it this way, but just as there is an uncanny valley for us when we're looking at a image of a human that isn't quite right, I think there also is when it's a story that doesn't quite work or feel like how people behave, or a world or setting that that doesn't. I think that there's a very similar powerful reason why we need human storytellers still to be wielding a lot of these tools, or you end up in the uncanny valley of the story not feeling like it depicts humans properly, even in non-visual ways.
Mm-hmm.
Which is neat to think about.
Yeah, that's very interesting.
Yeah. I mean, I often hear people talk about how technology sometimes gets driven by there being one particular application, especially an early application, that can be money making. I remember talking to some people who were part of the development of carbon nanofiber as a usable material. And right now, carbon nanofiber is in a lot of stuff. My laptop is cased in stuff that has carbon nanofiber in it, and so on. But that when they were early on in this, and they were getting grant money, as any research does, but they sat down and thought about it, and so they said, okay, if we do this, early on when it's still expensive, we can sell it as golf club shafts. The other one was bicycle frames, which is a place where people will spend big money for slightly lighter and stronger. And so they contacted companies that did golf clubs and bicycle frames and got a whole lot of funding through those little niches to then develop it to get to the level that it could then be cheap enough that we can now put it in lots of things. So in a way, we think of sometimes when science is trying to gain funds through capitalism instead of through grants, that it'll go to sort of niche but wealthy usages. But I think a good way to think about it in terms of the ones that are being developed for entertainment is it's almost the opposite of niche but costly. It's the lots and lots and lots of people will use this, but it's a really important and hard arena depicting humanity and storytelling. And therefore, it really, really needs the best, latest thing if it's going to innovate. The option of not innovating and just having people reading Shakespeare aloud against a blank screen still works, and works better than bad CG does, right? Mm-hmm. That you need very good technology to compete with the analog tools we have already for storytelling, and to help those get stronger instead of make them get weirder.
Mm-hmm. Yeah, I'd absolutely agree. And I think, entertainment in general does work that way as a kind of, as a wedge or like a fulcrum point where you can apply a lot of pressure to try to compete with the full power of human imagination that we're capable of leveraging in these analog media. And especially because it's a case where the human discontentments and the hedonic treadmill can kick in a big way.
Can you say what you mean by hedonic treadmill?
We get used to what we see. And so a video game in 1995 with very blocky but technically three-dimensional graphics was wowing everybody at the time, and then everybody caught up to it, and the way to wow everybody at that point is to get slightly better. Mm-hmm. And so you're constantly caught on this treadmill of the better you get, people will rapidly get used to that, treat that as
the new normal.
Exactly. You go from state-of-the-art to bog standard to behind the times, and so there's always going to be this pressure, and there's always going to be a financial incentive for people to do a little bit better and do a little bit better.
This is one of the problems that CG academic projects have often run into. There will be all this work to make a super awesome 3D model of Rome or Pompeii that you can walk around. But because academia, when it cuts corners, often cuts corners by spending more time and less money, because it doesn't have money and it does sometimes have time. It'll inevitably be the case that by the time the beautiful CG model of Rome is done, the graphics look out of date to everyone, because the video game industry has iterated 3 levels of CG quality while the academic model of Rome has been being made.
Yeah, absolutely. We run into similar problems with some of the media outreach in planetary science, where we'll do this extremely cool, you can walk around the surface of Mars in a full VR environment, and when they're showing that off at a conference, the year it comes out, it is absolutely the cutting edge, and it blows everybody's minds, and there's lines out the door. And then 6 months later, somebody can do better.
Right.
Which is not to say that it's still very, very fun to walk around on the surface of Mars with your VR goggles.
I walked around on the surface of Mars with my VR goggles, except that we couldn't figure out how to have a chair, and then the chair was in midair, and then we couldn't figure out how to get the chair to go away. And also, it put all of us in spacesuits so that we couldn't tell who was who because all the spacesuits looked the same, and we couldn't turn them off. And it was really funny.
Yeah. Yeah, and I think to some extent, academia and scholarship, we're still looking a little bit for our own killer app, so to speak, for VR and a lot of these newer technologies, because we do use them sometimes. At least, I've had occasion to use them on the job, so to speak, but somewhat rarely. And one doesn't want to say gimmick, but it didn't become a central part of research practice.
Yeah, I had a similar experience where I've done conferences in VR, but they just always didn't work as well as Zoom or another just straightforward video conferencing method, which wasn't as fun, but was much more effective.
Yeah, and I was talking with a science anthropologist a couple years ago who was really interested in this question, and we had a conversation about the ways in which these things which are so much pushing the envelope for entertainment and are so useful, sometimes but don't always intersect with the needs of professionals out there on the edge of inquiry, because we need so much more than just to be enthralled.
And there's also the thing where if it's entertainment, if you're being told a story, you're being guided through a story, and then you can make it really great. But if you want to have a conference in it, you're going to break it, because you're not being guided in the same way, and you're needing to do more things. One of the real problems with 3D simulation right now is actually doing the players' faces, which is what you want for a conference, right? A conference is multiplayer. You all want to be in the room and see each other in the way the Zoom will let you do with a camera, however pathetic it is, or GatherTown or whatever. You can see the people's faces. But when you're using the 3D thing, very obviously you've got goggles on your head.
Yeah.
And you don't have a camera that's 3Ding your face in real time to show your expressions. And that's a real hard problem that they're working on for games. And when they solve that, it might make the conference thing better, but there'll still be problems because what you want to do isn't the thing that it's set up to do that the games are so good at giving.
Yeah, absolutely. And another example I can think of is, for example, one of the things that I've been doing recently is setting up some research portals for our undergraduate researchers in the lab that need to be able to click through and analyze a lot of satellite images at very high volumes very quickly. And what they need is absolutely not any kind of 3D panning around or anything like that. What they need is, a website or some interface where they can very quickly click through in a fairly bare bones way. And what I need to do to be able to set that up is not even like a standard Windows environment where I have, a graphic user interface and I'm using the mouse. I'm all the way back down to the command line, right? And that's what's needed for that kind of work in that way. And it doesn't look as flashy, certainly, but there's certain kinds of abstraction that only that kind of interface can provide.
So this is letting them look at a crater and then say this crater is in category A or category B?
Or more precisely, is this a crater or is this not a crater? We've been taking satellite images of Mars for so long that for just about 2/3 of the surface, we have at least 2 such pictures at some known interval of time.
Right.
And so what we can do is compare the before and after of those and say, hey, look, there was a new crater that showed up in this time. And so I am guiding some undergraduates through a project that will allow us to understand precisely how often new impacts are happening across the surface of Mars.
Now, I remember a point when you were working on a program to teach the program to identify craters.
Yes.
Because of the problem of, when you have an entire planet, having a human being look at the picture and say, this is a crater, this is not a crater, this is a crater, takes an enormous amount of time because it is a whole planet.
Yes, exactly. So we have multiple layers of software in different languages that can go from like, okay, this is the area of Mars we're interested in, to, okay, boss, I've downloaded all the satellite photographs. I have purely algorithmically compared all of them, and I think here are my 1,000 most likely possible fresh craters in that area. And so then the trick is, even then you've got still 1,000 images, and so you're going to need some human hours put into this.
Right.
And in Mars research, that is absolutely one of the fascinating problems of, okay, we have so many scientists that are interested in these problems. We only have so many scientists, and we've got a whole planet.
They're very big, really. Even a small planet is actually very big.
Yes, it's so easy in the human imagination to let Mars become human-sized.
Mm-hmm.
And, not even Earth is human-sized, and we've been here for, millennia. We've been studying it.
Yeah. I think one of the things that makes that easier is the fact that the surface, especially in the photos that we look at, is fairly homogeneous. So it's easy to imagine it as, well, it's basically one thing. It's like you go to the store that has the plushy versions of all the planets, and some of the plushies are complicated prints on them because they're patterns or they're swirly, or Earth has continents. But the Mars one is just one color all over, except for the little tufty ice cap on top, because Mars feels homogeneous because of its monochromeness. Same being true of Venus in a lot of ways. And so I think that's another reason studying Mars feels like it should be the same scale as studying the Amazon, or studying the Sahara Desert, or studying Antarctica.
Right. Whereas, of course, Mars has the same dry land surface area as the entirety of Earth.
Right.
And is every bit as varied.
And it has higher mountains and lower crevices and a very long river.
Yes. And I know at least one guy who insists that Mars will have the largest gold deposit of any planet in the solar system. So, no, it's got tremendous variability. It's got tremendously...
It's never going to beat us on
regions.
gold, though. Viking sources make it very clear that if you have a pile of gold and you get a small snake and you put the small snake on the pile of gold, the snake will grow if you feed it, and then the pile of gold will also grow under the snake. And then eventually the snake will be an enormous dragon, and there will be a huge pile of gold, and then you need a hero to kill the dragon, and they have lots of gold. So, Mars doesn't have snakes, so it won't win at the one.
I see the problem now, yes.
I was going to say that there's an Arthur C. Clarke book that I read as a kid where it compares the sizes of Earth and Jupiter in a way that has always stuck with me. And they're actually in a hot air balloon over India when they're having the conversation. And he says that if you skinned Earth and spread it out on Jupiter, it would have the same surface area as India does on Earth. Which, when you're looking at a globe, you know how big India is on a globe, and it's still pretty big as a comparison. But if you're in a hot air balloon looking down on India, then it's vast. And you're really aware of its vastness in a way that it's also small. And Earth is also vast and also small, and Jupiter is that much bigger again. And it's a wonderful, poetic bit of science.
Yeah, it's gorgeous.
That has always stuck with me.
Yeah. Well, particularly because when we compare Earth and Jupiter, we don't usually compare surface area, we usually compare the spheres, and Earth is a smaller sphere. Yeah, Earth feels even smaller compared to Jupiter than that way of doing it, which makes Earth feel bigger.
What Jonathan just said about Mars having the same land area as Earth is similar. Yeah. We don't think of it that way, and it's a brilliant, fascinating way to think about it.
Yeah, and I think that knowing how to understand these things is often of tremendous value in helping people understand. I admire anybody who's capable of creating that kind of material poetry, I guess you'd call it. Being able to give humans a more direct experience of these things that are otherwise outside of our ability to comprehend and say, well, okay, it's like this.
Yeah.
And you go, oh. I think Feynman famously was one of the best at this, but there is a particular talent out there of science communication that can do that, of which Arthur C. Clarke was obviously an incredible talent.
It's the sort of thing XKCD does a lot too, and that you sometimes see governments trying to do. Things like communicating how contagious COVID is compared to flu, for example, or communicating what airborne transmission actually means, resulted in a lot of very interesting visual efforts of how do you make a diagram that gets this across. Do you use color? Do you use shape? Do you make it abstract? Do you have images of people? And there was such a huge and fascinating range of attempted communication tools for getting across, the relative contagiousness and relative dangerousness of different diseases compared to each other.
I do think it's one of the things that science fiction does very well, because it's giving you a story, as we were talking about before. It's feeding into the human need for story while also doing these kinds of connecting explanations of things.
Yeah.
Yeah, absolutely.
Which could be a good way to transition into talking about the other thing we wanted to talk about.
Yes. Yeah, and I think that so science fiction gives you narrative and story and sort of imagined lived experience to understand the thing, whereas diagrams and proportion comparisons give you something that's often imagined in a visual or tactile way. How big would this be if I touched it, if I had it in my hands? Things that compare stuff to fruit and other things that you've seen and held. Okay, so I remember a point when Joe was working on a chapter and a character was on Mars, and Joe kept messaging Jonathan saying, "Oh no, my character is sat down on a rock. Jonathan, help me. What is the rock like?"
That's right.
And I think I came up with black and prickly.
Yeah. You came up with some very, very good solutions to the problem that my character was making for herself by walking around on Mars, on a partially terraformed Mars. And it was a Mars in a state halfway through the process of being terraformed, and so that affected how things looked and everything, and you just gave me terrific answers that I could just slot straight into what I wanted, which hasn't always been my experience of trying to get answers, because if you say, I don't know enough science to write science fiction, the answer people give you is often yes, but you can ask scientists, and scientists are really happy to give you an answer. But not all scientists understand the way to give you an answer that you can use. And all too often I've had the experience of people saying, no, they couldn't possibly sit on a rock.
Or parallel things. Sometimes I've had this experience actually quite a bit with Terra Ignota when asking people who deal with space tech and space colonization tech. And, I'll say, here is the parameter. And they'll say, no, that would never happen. And I'd say, why? And they'd say, well, because, Earth is way too violent. They would totally have had World War IV by then. There's no way that your world build would happen. And I'd be like, that is unrelated to the question about how the space elevator would work. And people will refuse to say, which will be one of the troubles. But I remember the really lovely example that I think gets this across, Jonathan, was when you were asked by a science fiction writer, I want to have a savannah planet. How can I have a savannah planet? And the straightforward answer is you can't. You can have an ocean planet, but Jonathan, can you talk a little bit about, the kind of answer you gave, which is very different from you can't, but also very different from you can?
Yeah, that was I felt kind of bad about that one because I tried really hard to make it work.
I thought you came up with a great solution in the end, but it requires the try, in this neat way.
Yeah, to kind of echo the general sentiment, scientists and domain experts are often very, very happy to provide answers when you ask them questions, but I think far too often the answer is no. I think that the way to approach these things that I think, in my experience, tends to generate a lot more satisfaction for everyone involved and a lot better stories is to yes and.
Yeah. Or the yes, but you need X.
Right, exactly. The difficulty in constructing a savannah planet is that unlike an ocean planet, the surface can't move around to balance the heat. You know, when the equator is much closer to the sun, no matter where you are in the orbit, you've got the radius of your planet difference. You're coming in at a much more acute angle towards the poles, so the heat is coming in. And so any kind of just generic orb floating in space will heat up near the equator, cool towards the poles, and then whatever atmosphere it has will try to convey that heat as much as it can to balance it out. But on an ocean world where that water can absorb a lot more heat and flow around very elegantly, it's okay.
And that's how you can get a homogeneous-ish ocean planet.
Right. You know, there's still going to be differences at the equator and the pole, like temperature-wise, but it can fundamentally be a liquid all over. It can be an ocean planet. But the temperature differences in a savanna are difficult to balance out because the equator is going to blister to really kind of a desert environment, even as the cool temperatures near the poles are going to keep things very like snowed under.
Right.
And so the central case of a savanna that you imagine when somebody says the word savanna, these beautiful wavy grasslands, archetypically on continents like Africa, where you have these like beautiful, large, robust ecosystems and rich, loamy soils and so on. There's going to be more variation than that. It's much harder to get the one environment, the one ecosystem
right,
everywhere.
Because you could have a planet that has two big strips of savanna with a deserty equator and a frozen-y poles.
Exactly.
But if you want to not have that deserty equator and not have those frozen-y poles, it gets a lot harder.
Right, and so we tried, we were bouncing all kinds of possible ideas back and forth. It's like, what if the planet had, square blocks that were lifted up to, block wind flows, or to have different elevations at different latitudes, things like that. What if you put up giant walls? If we're willing to go for a very artificial world, for example, might we sort of convey it that way? Or, what if you had some geologic phenomenon that was able to, under the surface, convey heat much more efficiently than mere gaseous atmosphere, and so you can warm the poles much more readily?
Right, like if there's a subterranean shell of metal that's super heat conductive somehow.
Right, yeah, or even moving some sort of super heat conductive fluid from the equator to the poles underground. Yeah, I mean, and so, like, this, and in the end, there are ways to do it. And it just sort of requires a little bit more creativity. It requires a little bit more, I'll say industry on the part of the author.
Well, and on the part of the scientist as well, who's the one who has the, if I asked you, I want a savanna planet, I wouldn't be able to tell you at the start that a subterranean thing would be the solution, but you can describe to me the problem. And then I can start saying, so are you saying if the Death Star is metal on the outside and we cover the Death Star with dirt, that can be a savanna world? And you'd say, well, that might do some of what you need.
Yeah, and then we get this back and forth. But I think you really hit on it there. Talking about, okay, well, what if we do this thing? And often you can get the result you want if you do a thing. And in my experience, and one of the most satisfying parts of this process is that very often when you're talking with the author who's in the planning stages of the story, trying to make it go back and forth, whenever you start describing a thing, all of a sudden, a lot of the story will start to click for them, and the thing will become very exciting.
They'll say, that'd be great to have there be a subterranean blah, because it can blah with the...
Yeah.
Right.
Would it work for the planet to be a cylinder? Could you have a savanna cylinder planet?
Oh. A savanna cylinder would solve most of your problems.
You'd have the cylinder has other problems.
Yeah, the problem is that a cylinder doesn't have a geoid. Gravity gets screwy. And so I'd have to sit down and think about what happens to gravity over the surface of the cylinder. But as you left the equator, you'd get heavier than lighter. Weird. I think it would be very odd.
And then maybe the trees could be like bigger and then smaller, or smaller and then bigger, because trees grow to the...
Or like narrower than thinner for the same height.
Ooh.
Yeah. It would be a great habitat for my people who develop the ballet dancing, which is ballet done in variable gravity.
You can perform the same ballet at different gravity levels. And
Yep. It would be very good there, yeah.
Yeah, this would also be consuming quite a lot of energy on a continuous basis.
To not collapse into a sphere.
Well, and also to not flip the wrong way around. I believe it would collapse. It would try to collapse with one of the circles towards the sun.
Yeah.
So I've actually just got a perfect example of what you were just talking about, because as you said that, a lot of energy not to flip the wrong way around, I thought, no, what I want is the one that somebody made a long time ago and abandoned, and now it's flipped the wrong way around. And people are trying to figure out what the heck it was for.
It was a giant
see?
savannah ecological park that somebody made to like preserve savannah animals long ago, but then the project was abandoned and it flipped around the wrong way and it stopped being a savannah. And so you have these weird things living on it that are like descended from former savannah organisms.
So what would it, after it flips, what would happen to that? Yeah, it's a fascinating question, you know. And it just comes out of suggesting the actual science, which is like actual history, always more interesting than the thing that you would make up.
Very much so. Because the same question is always true with historians as well. People come to a historian and say, can I have X in Y time and place? You know, the unfruitful answer is no. The fruitful answer is, well, let's think about what they would be able to do and, you know, what it would require and different ways that it could be there.
Yeah, and I think science fiction is an especially fun place to do this because it's never really just about nature. You know, like there are stories about going out and exploring exciting natural phenomena and so on, but almost always science fiction is about the intersection of intelligence with nature. And how these kind of feed back into each other. And when you add intelligence to nature, very few things are flatly impossible.
That's a great line by itself.
That's wonderful, yeah.
I want that on a t-shirt.
Yeah, and I think that often where the great joy of science consulting with science fiction comes from is exploiting the training that this discipline gives you, not in encyclopedic knowledge of natural phenomena, but in the ability to follow consequences out and maintain a self-consistent cosmos.
So what you mean is actual science?
So to speak.
No,
yeah,
it's not taking measurements and doing experiments. It's using the scientific method with the knowledge that you have to follow it out. That's actual science. That's so neat.
Yeah, and I think it makes stories so much richer, so much more often. Where if you say, okay, this can be true. Here are 3 different ways to make your request true. Here is what else has to be true in a self-consistent cosmos for each of those 3 things.
Yeah.
And then often I think, the people that just say no are missing out on a really golden opportunity to come back to the author and say, what happens to your story if?
Yeah. Well, I remember when I have been asking a number of scientists about recently, which is, I want an organism that has a method where you can eat its brain and the knowledge passes into the person who's eaten it. And I get a lot of, no, that just can't happen. You digest the stuff.
Right.
But then you get the, okay, well, what if the neurons are each like a little tiny microbe that also can swim and are also acid resistant and sort of parasite-like. And when the brain tissue hits digestive fluid, they activate and sort of disperse and swim out through the walls of the digestive system into the body of the host, and then make their way to somewhere where they reassemble, recognizing which ones should be connected to which other ones. And you can then reconstruct.
Right. The process of digestion maps out neurons.
Right. Yeah. So that the process of digestion digests the other meat, but it doesn't actually digest the brain tissue. It just gives the brain, little nematode things, the opportunity to enter into a system and then move through that system the same way microbial parasites are evolved to move into and around a body. And some microbial parasites seek out the liver and stick to it. There's no reason another couldn't seek out others of its colony to reconstruct a colony within a host organism.
And don't worms sort of do that anyway?
Well, slightly.
Yeah, like, I mean, like, yeah, not really
Yeah,
on that microbial level.
Yeah, and they don't like reassemble themselves into a structure they had before, but a sponge does.
Yeah, and so all of a sudden we get this really interesting question that Joe brings up is like, what's the rest of that ecosystem look like?
Exactly.
Phylogenetically, what are the precursors? What
Hmm.
ecological roles did these fill as they developed?
yeah. A
Yeah.
question I often ask when I'm developing aliens is what were these aliens like when they were animals,
Hmm.
before they were intelligent? Because you get really interesting answers to that.
And in many stories, it's also fine to say, you know what, these aliens eat each other's brains and then get each other's knowledge. And I'm not going to go talk about the science. It's just going to be the case. And that's fine. And, great stories do that. Heck, in many ways, Book of the New Sun does that.
Sure.
And that's, cool and fine. But sometimes when you do the science, it's that the science then leads to new story hooks.
Yeah.
In which we think about what else, what can kill the nematode-like brain cells? What did they used to do? What else can they do? What happens when they interact with organisms that are not evolved to have them in them? All these other cool secondary things that can then become hooks for story. Just as if we were working with the savannah planet and then you say, okay, well, you need this complicated subterranean system, then suddenly, oh, neat. Does that mean that once intelligent life develops on the savannah planet, they can use the subterranean fluid to, send each other signals? Or can there be whales in there that they talk to that live in the subterranean super heat conductive fluid? And so the story blooms from the yes and in exactly the same way that if someone comes to me and says, okay, I want to write a story and it's set in Renaissance Florence, but I really want to have a ninja. Can I have a ninja? And I can be like, well, it's hard, but let's think about how a person from Japan could end up there, or how a person from Japan could end up near enough to transmit ninja culture to somebody else. Let's talk about ways that shipwrecks can help this. Let's talk about the Silk Road. Let's talk about the real travelers from places that, we have people coming from Japan 170 years later. Here are the reasons that it happened later, not earlier. What can we tweak? What can we do? And pretty soon we either have a really nifty journey where we also have interaction with a lot of elements of the Silk Road, or we have a really interesting shipwreck so that Indonesia is in our picture. And that leads to cool story stuff and a new secondary character where the ninja is married to somebody that they picked up after shipwreck number 1 in Indonesia, and that's way cooler. Or it leads to the, oh, neat, well, let's make this a slight alternate history where this cultural phenomenon happens earlier and this cultural phenomenon happens later, so that the factors that mean that there are Japanese people who make it to Renaissance Italy 170 years later than you wanted the book to be set can happen already. And all of these things lead to plot hooks that just can become a really rich element of story building by saying yes and instead of either no or just drop it in and don't worry about explaining it. Which is sometimes the right answer because you don't want those other things in the story. You're busy with other stuff. This is a action comedy, and we want to focus on the awesomeness that is being a ninja in the Uffizi, and we're not spending our time on logistics. We're just having our ninja be a the Uffizi. Sometimes simplicity is good.
And in the case of science fiction in particular, I think that you can often not just get away with not having explanations, but it often makes sense not to know everything.
Yeah.
Certainly from the perspective of your characters. We started out this conversation talking about all these exciting open questions on Mars. Mm-hmm. Like, landing our first robot on Mars did not provide us a bullet point list of all the true Mars facts.
Right.
There's always going to be these beautiful open questions, and often the ones that you want to focus on for your story are not going to be just the places where you've thought of an explanation, but a narrower subset of that, even where you want to illuminate to your readers or to your audience to describe the universe in a particular way, to get them thinking about the narrative as having a particular structure and living in a particular kind of world.
I also want to make a quick and important pitch for, this is going to sound nuts at first, having these kind of conversations with scientists, even when what you're doing is a fantasy world build. Not just because of things like we're interested in how the geology of Tolkien works or whatever, but because sometimes when you ask a scientist this thing that I'm just going to have magically be the case, how would it work if it were science? You'll get an answer that'll lead to a cooler world build. So like I was hanging out with some chemists and I was saying, okay, in this world, I want there to be a magic thing that can happen that makes somebody's blood then be a different color. And the chemist's first answer was, do you want the color change to be caused by one chemical compound or multiple separate chemicals that are absorbing different wavelengths of light? To which I was instantly like, ooh. And then there could be a part way where you have one of them but not the other, and there could be several colors of blood depending on whether the first phase or the second phase or both have happened. And the next question was, do you want to do it with a pigment, or do you want to have them use the alternate form of hemoglobin that fish have that makes your blood kind of bluey whitey instead of red? And so suddenly I'm thinking about a range of different blood colors, and I'm thinking about whether mer people might all by default have the blood that people associate with having undergone the magical ceremony, whether that could create an interesting cultural tension between people and mer people if this ceremony has a stigma or something. I've been given a bunch of neat ideas I wouldn't have thought of otherwise, even if I'm not planning on having science.
And on that same note, like, as a geologist who's a huge fan of the fantasy genre, please consciously consider whether you actually want your fantasy world on a planet or not.
Yes.
It's allowed to be flat. It's fine. you know? Fantasy in particular offers so much more flexibility in terms of how land masses are constructed, what the world looks like.
Yeah.
I do, in fact, have a fantasy novel that takes place in a cylinder.
And it's really neat. Well, and as you know, Joe, because you've read it, my first unpublished novel that I ever finished when I was young, right, is on an infinite flat plane.
It's amazing.
I will probably rewrite that in good words someday.
The world building in that is really fascinating.
Yep, I will revisit that world building at some point.
Yes, that'll be kind of nifty.
This has been a great conversation. And now, by tradition, we end with... First, each of us will gush about a book, any book, or more than one book if we wish, that we have been excited by lately, any kind of book, no matter what it is. And then finally, the administrative podcast stuff.
But first, Jonathan, where can listeners find more of your amazing stuff?
For my popular science outreach, I have one guest post on Ex Urbe called What Color Is Pluto that I wrote in anticipation of the New Horizons flyby. So you can go back, read that, and check my work against what reality ended up actually being. And you may have occasionally find my name in sneaky little places in acknowledgements sections of a few books here and there that you might find in Barnes & Noble for different authors that I've had the privilege of doing a little bit of advising on. Some of my best work will be hidden away in nooks and crannies in some books that you're probably already reading.
Including some books by people who are on this podcast. So, Joe, what is a book that you've been excited by lately?
I've just finished reading a novella that is coming out from Tor.com next year, which is called Spear by Nicola Griffith. And when I was asked if I wanted to read a feminist retelling Arthurian thing, my fingers were poised over the N and the O key on my keyboard because really that was the last thing that I wanted to read. But then when I saw that it was Nicola Griffith, I said yes because I really love her work and I trusted her to be doing something good and exciting. And in fact, it's brilliant. She knows what she's doing. It's good and exciting. It's not at all, feminist retelling of Arthur. I guess it is, but that's not what it's about. That's not where its focus is. It's this wonderfully mythic thing that is just lovely. And it's beautifully written. It's beautifully constructed. I thoroughly enjoyed reading it. It's just great. I was going to read just a little bit of it, and I read all of it.
Awesome.
Brilliant.
Jonathan, do you have a book that you're excited by lately of any kind?
Absolutely. I've been an absolute David Mitchell bender lately.
Hmm.
David Mitchell writes in an interesting interstitial place between science fiction and literary fiction, and he writes all of his books in a shared universe with some recurring characters and recurring science fictional phenomena. And so it's this absolutely exciting process of you pick up a David Mitchell book and it might be set at the sort of Dutch embassy in Japan centuries ago, and it's about a person's encounter with this different culture in the mode of shogun, except that it's David Mitchell. So even though it's written in this literary fiction style, you know at some point something impossible will occur, and it'll give you another piece of this puzzle for the larger, what is called the David Mitchell Uber novel, I think they call it, where everybody's waiting across this career as book comes out and book comes out to sort of understand what happens to human history between 1700 and 2200 across every shoreline in the Pacific. You've probably heard of him most likely as the author of the book that was turned into the movie Cloud Atlas by the Wachowskis. But I find the best place to start is The Thousand Autumns of Jacob de Zoet, which is the earliest chronologically of all his books.
Neat. The structure is making me think of Phoenix and of Tezuka's multi.
Exactly.
Yeah.
Absolutely. Especially because, not to spoil it, but some of the science fictional phenomena are related to very similar themes.
Neat.
Very neat. Yeah. So, Ada, have you got anything for us?
Well, this morning I was newly reinforced in my love of Rudolf Simek Dictionary of Northern Mythology. There are a bunch of different good reference books where when you need to look up a Viking thing or a Viking myth thing, and you're like, I forget which of the 8 fairly interchangeable goddesses that hang out with Frigg this is, you can look them up. And there's a bunch of them that are good at that. But the thing that I find outstanding about the Rudolf Simek one is that in the entries, he also indexes the old erroneous theories about things that we don't believe anymore and where those came from. So you can look up a thing and it'll say, Loki isn't a god of fire. We used to think he was because of blah, 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 blah. Here are the 19th century scholars whose work was the origin of this misunderstanding, and here's the source of how we got out of believing that and why we don't think that anymore, why we think this other thing. And a lot of these encyclopedias only give you the updated version. And so if you've run across a reference somewhere of claiming that like Uller is in some complicated way closely related to the Vanir and or the true identity of Sif's first husband, you're like, what is that? You can usually look up Uller in Rudolf Simek and you'll get, here are the generally now discredited older ideas about this figure that you might still run across in stuff. So it's an invaluable tool because anything that's dealing with Norse myth, whether it's fiction or nonfiction, is wading through this huge morass of discredited, outdated versions of things, which often make it into new stuff. And it's very difficult to keep track of which of this is a new reading that we think is the case and which of this is an old reading that we don't think is the case, but that the author of this didn't realize we don't think is the case and they were using it. Or they did realize, but they were throwing it in anyway because they're making fiction, and fiction can use outdated versions of things because writing a novel that takes place on a flat earth is really fun or whatever.
Yeah, I sure wish there was a Celtic equivalent that did that. That would be so valuable. Yeah.
And so I'm constantly there, it's not the most up to date for the newest stuff, and it's not the most robust, but boy, is it indispensable when I'm trying to figure out where a strange reading of something that I'm not familiar with came from, or why 2 versions of an interpretation of something are there that we don't believe one of them anymore. So Rudolf Simek, Simek, Dictionary of Northern Mythology.
So thank you, Jonathan. Thank you ever so much for being on the podcast. It's been really, really fun, and we really want to have you again and talk about more things. That was amazing. Now I'm going to do the boring bit. This podcast is released under a Creative Commons Attribution Non-Commercial No Derivatives International 4.0 license.
And you can support us and get episodes in advance at patreon.com/Ada Palmer and support Jo and get her wonderful poetry at patreon.com/BlueJo.
And you can find us on Twitter and our books and things at joaltonbooks.com and adapalmer.com. So, until next time, Ex Urbe ad Astra.
Ad Astra.
Ad Astra.